Good afternoon and welcome to another webinar of AppsCode. Glad to have you all here with us today. We have an insightful webinar here featuring one of our experienced engineers, Anisur, who has been involved in this project for a while. Before the session begins, I want to remind you that your participation and engagement are very important to us. If you have any questions during the webinar, please feel free to ask them in the Zoom chat. We'll address them during the QA part of the webinar. Without any further delay, let's dive into the program. Over to you, Anisur. The floor is yours.
Well, thank you. And first of all, I want to thank everyone for joining today's webinar session. And our today's webinar session title is Seamless Credentialless Backup and Restore with KubeStash on Amazon EKS. So let me introduce myself. My name is Anisur Rahman, and I'm working for AppsCode for last two and a half year. So let's go to the webinar session. So here is a table of contents. This is the snack overview of our whole today's webinar. So first of all, I will discuss about
Sir, I'd
the
like to
disk of.
request you to share the screen so that we can also watch.
Oh, sorry. Is it visible now?
Yeah, it's visible.
Okay. So here is the table of contents section of our today's webinar. So the first content that I will talk about is the risk of traditional credential management of any Kubernetes cluster. So then the next topic will be how KubeStash solve the credential management complexity inside any Kubernetes cluster. So today's we'll talk about only the Amazon EKS cluster. Then the next I will also discuss about setting up credentialless backup on EKS. And after that, I will also show a demonstration of the credentialless backup on EKS cluster. And finally, there will be also a question and answering session. So the first slide is the risk of traditional credential management. So yeah, there is lots of security challenges and operational overhead while you are using a traditional credential inside any cluster. So let's understand some security challenges and operational overhead of credential-based backup method inside any Kubernetes cluster. So there are many security challenges. So from them, I only will talk about only three of them, which is hard-coded secrets, over-provisioning access, and secret rotation overhead. So what's actually the hard-coded secret? Basically, credentials are very often used to store inside a YAML file as a plain text or any script or environment variable of image, pod image. So therefore, there is a lot of chance that anyone who has the kube config can access the secret and view the secret and get the credentials from it. So yeah, this is there is a options of security leaks. Then the next security challenge of it is over provisioning access. So to reduce the friction, and many large DevOps team actually give a broader access of credential. For example, in for the EKS, AWS, if a user need to only access the S3 access, sometimes many DevOps team actually give access to restart their AWS service. So that's actually increase the vulnerability as well as violating the principle of less privilege in cloud system. Then the next security challenge is secret rotation overhead. So it's quite challenging to manage the secret manually, to note down when the secret will be expired and we need to invest a lot of time to operate the secret rotation one by one of every workload application. So yeah, it's quite time consuming and very tedious stuff. And not only that, it also increase the downtime of the application. For example, some banking application which are hosted inside any Kubernetes cluster, there is, if this cluster using the traditional credential management, then for a while and after a certain amount of session or time or month, we have to rotate the secret, so it's increased the downtime of the application. So these three are the major security challenges of using traditional credential management. And not only that, there are some operational overhead, for example, manual provisioning. So what actually does mean of manual provisioning? So in today's webinar, we are only focusing on AWS EKS cluster. So let's consider it. So suppose for manual provisioning means actually user have to create the policy, identity access management policy as well as identity access management role. So and you have to create the necessary policy. You have to add the necessary policy to the and attach it with the role. So this is really a complex stuff sometimes. So this actually faces some operational overhead to the any DevOps team. And there is also a audit complexity. So audit complexity means actually tracking who access what actually. So if there is a large DevOps team and many team using the shared credential, so in that case there is a chance that someone violating the rules and someone violating some another AWS services. So all of those managing those stuffs is really quite complex. So yeah, that's all about some risks of traditional credential management. So now let's go to the next slide. Uh, uh, here I will discuss about how KubeStash, this is one of the graduate project of Fscode and solves the credential complexity. So to understand how KubeStash solves the credential complexity, we have to know a little bit at a high level overview of how KubeStash work actually. So you can install KubeStash easily by through help. So it's quite easy stuff. And if you want to start taking backup of any application inside a Kubernetes cluster, the first thing that you want to create is backup configuration. So this backup configuration will contain the targeted backend application which you might want to take backup, and also the backend and also the backend information, for example AWS S3, GCS, Azure, where you actually want to store your backup data, and also some other information like schedule, how much schedule you want to take backup, for example hourly schedule or monthly, weekly schedule, monthly schedule, or yearly. It's up to the user. So once you create a backup configuration targeting your desired backend, desired application, workload application or database, whatever you want, a KubeStash operator watch this backup configuration and create the backup session. So the backup session means the schedule that you provide inside your backup configuration. So KubeStash operator then create the snapshot. What actually the snapshot? The snapshot means actually the actual backup data. Snapshot contains the backup backup information of the data. So uh, after that, the KubeStash operator also create the job. This job is actually the responsible for dumping any database or taking file system snapshot of any workload application, for example for a stateful set application or workload. So the job take the file system backup, and for database dump the database and take the snapshot of it, and and buffer those snapshot data into the AWS S3. So in our today's session, we are considering AWS S3 bucket. So that's why it can be any storage service, for example, S3, GCS, or Azure, or any S3 compatible, however it is. So just consider that this job is responsible for taking backup. So then the job must have the credential to communicate with the cloud service, right? So here we don't want to use any credential, uh, want to use credential. So KubeStash cooperate with AWS some service like AWS IRS service and manage those stuff automatically. So yeah, we don't need any secrets. So we will know about how KubeStash manage those secrets and how actually it works. We will know and discuss little more about it in the following slide. So here is a high-level overview actually how AWS cooperate with AWS EKS cluster and take backup and store it into its on-off service S3. So let's consider this is a Kubernetes EKS cluster, EKS Kubernetes cluster. So so here actually you have to create, firstly you have to create an YDC provider for this cluster. So along with YDC you have to add some policy and role with this YDC provider, and once you add some role, every role has some earn value. So let's consider this is an earn value. So here the account ID is actually what account you are using to create the cluster, and the role is the role name on which role you are attached with your YDC provider. So KubeStash operator, you have to annotate this earn value with KubeStash operator service account. That's mean KubeStash operator has a service account, and the service account has this value as an annotation. So once KubeStash operator trigger any job, so this job definitely has a service account. KubeStash also responsible for creating this service account. So once the KubeStash operator service account has any earn value of EKS cluster, EKS YDC, AWS YDC provider, then KubeStash actually also add this value to the backup job service account. That's mean uh, the backup job service account also has the same access what the KubeStash operator has. So this service account is when actually let's say that service account has the annotation, then how actually do service account identify as a gateway for OIDC for the credentials or token from the OIDC provider. So we will also discuss about it, but if I say a little high level, then there is a AWS port identity OIVIC of control plane inside the EKS cluster. So every YAML that you apply goes through this identity webhook. So once webhook find that any pod has the service account, any pod has service account with the earn value. So this webhook communicate with the OIDC provider of AWS and get the credit get the temporary credential from it, and append those credential to the pod environment variable, as well as the mount the security pod, mount the security token also. So this token is actually so when the job or when the pod actually try to connect with the AWS S3, so this pod SDK use the credential chain and use those credential and to resolve the authentication with the actual AWS S3. So that was actually the high level overview. I will also talk about it during my demonstration session. So so here I have to setting up credentialless backup on EKS. So to set up your EKS cluster credentialless, you have to first create an IAM OIDC provider for EKS cluster. Inside the slide and inside there I also referred the link, following link. This is a really a sample follow-up link, and by through this link you can easily create the OIDC provider of the EKS cluster. This is not the rocket science, it's quite easy. Just some URL or some command, or you can also add the create the OIDC provider from the AWS console. So it's really easy stuff, so therefore I am ignoring this. And secondly, you have to create a IAM policy with necessary permission. For example, if you want to if you want to provide the permission of S3, then you only have to give the S3 permission. So in our case, like for in our KubeStash, we only need the S3 service permission, so nothing else. And once you create the policy, you have to associate that policy with the web identity IAM role. And once you create the IAM role, you have to provide the cluster ID. And this is how the IAM role attached with the OIDC provider. And after that, you have to get the earn value of the role, and you have to annotate this earn value. You have to set the earn value as an annotation of the service account of KubeStash. So in that case, it will be definitely KubeStash operator. This is the service account what KubeStash use in EKS cluster. So here is the live demonstration section. So here we will also discuss a little more about the OIDC. So for the simplicity, I have created the cluster and created OIDC and some role earlier. So just I want to show you guys that how I annotate the service account of KubeStash. Here you see that I annotate my this is really confidential, so I am not going to use show you guys the annotation. So just ignore, just see this as a reference. This is the my earn value. Uh, so this service account will use to for backup job as well as the restore job, or any job or pod what is going to access the S3 bucket. So so I am going to talk about the backup storage. What is backup storage? So backup storage is a custom resource. This is KubeStash stuff. And let's think about the backup storage act as a actual bucket of inside any cluster. So once you apply a backup storage, KubeStash operator try to access your provided backend and try to communicate with that backend and establish connection. So here you see that I did not provide any secret name. I just comment out this one. I will delete this one. So in a traditional cluster, we have to give the secret name as AWS S3 secret, but right now as this is the credentialless, so I am going to remove this secret information. So let's see that there is no secret which will use to access the S3 bucket. So right now there is no secret, and if I go to the bucket, this is the KubeStash webinar bucket, and you see that there is no object inside of this bucket. So so now I am going to apply this backup configuration, and let's see that KubeStash operator can communicate with this bucket or not. Well, yeah, you can see that our backup storage phase is ready. So if we go back to our bucket section, AWS console bucket, then we will see that there will be a directory demo. This was our prefix as demo, and inside demo there will be a manifest like manifest.yaml, metadata.yaml. This YAML ensures that KubeStash can communicate with that bucket, and this proof that KubeStash has successfully communicate with that bucket. They have successfully established the connection with that S3 bucket. So that proves that definitely without any secret we can access S3 bucket from by using our KubeStash. So so later we are going to deploy we are going to see a real life example, like inside our cluster we have a bucket. Now we want to take back inside it. So for this one I am going to apply a sample stateful set application with replica 3, and each pod will contains a sample data.txt file. So each pod inside the source data directory there will be a definitely a file data.txt. So what we are going to create backup configuration by targeting this stateful set application. So let's apply this stateful set, and once it done we will also apply the backup configuration. So let's apply the stateful set first. Well, let's wait a little until on of stateful set pod goes to running state. You see that our stateful set pod is in running state. So what I am going to do right now is to exec this stateful set pod and validate that inside the source data directory there is a text.data file. So yeah, you can see that inside the source data directory there is a data.txt file. Let's get this one, and you see that there is a sample sts0 inside of so if I exec the next one, then definitely inside the source data directory there will be a sample sts1. So that proves that in every uh, replica there under the source data directory there is a file named data.txt. So what we are going to back up every replica and store into the S3 bucket. So let's apply the backup configuration as I mentioned previously, that for initializing any backup of any application, we have to apply the backup configuration. So here is the backup configuration. I want to talk a little about the backup configuration, as like inside the target section, I'm going to referring the stateful set application, which is under the apps API group. And for backend, I am going to use the S3 storage as I it's the bucket name as like the S3 storage as I previously created this one. So and I am using 5-minute interval schedule of taking backup, and I'm using directory of demo sample STS, and also I'm going to only taking the backup of source data path. So yeah, there is lots of more flexibility of taking backup, actually, of which path you want to take backup or which path you want to exclude during backup. You just go through the kubestash.com inside the workload application backup, and there you will be asked to see that how much functionality does kubestash have inside the param section. So here I am only taking backup of source data directory. So yeah, that's all about my backup configuration. So let's apply this one. Oh, our backups configuration is created. Just wait a little until it phase goes to ready. So yeah, our backup configuration phase is ready, and it also trigger its initial backup. Basically, this is the initial backup, and after this backup, in every 5 minutes schedule, it will trigger another backup. So yeah, it shows that our backup is actually backup session phase is succeeded. So that phase denotes that our backup session completed successfully. So if the backup session phase is failed, then definitely there is no backup. So if we go back to our bucket and just refresh it, and we mentioned that under the demo and sample STS, there will be a directory of repository, and inside repository, this is the beyond version, and you will get the actual backup data. Like for the replica 0, there is a directory dump pod 0. For replica 1, there is a dump pod 1, and for so on. It will be go under the how much replica you have inside your cluster of a stateful set application. So yeah, this is the actual data, and from the backend S3 bucket, we might not able to see the actual data because we are using encryption secret. So all of those data are encrypted. So we are not might able until we restore those data into another stateful set application. So this is how actually KubeStash ensures also the security vulnerability of encryption. There is no chance of any data leak. So right now I am going to apply, create another stateful set application. So here you see that there is no data inside. There will be no data once we will trigger this stateful set application, and we are going to restore the our backup data inside of it. So let's apply this one. So our sample restore stateful set is also created. So I'm going to exec this pod also, and showing you guys that inside the data source data directory there is no data.txt file. So let's exec this one again. Just go to the source data directory, and you guys see that there is no data.txt file inside of this mount path directory. So once we create our restore session, our restore session will communicate with create another job, and this job will communicate with AWS S3 and restore the data inside of this directory. So I am keeping uh, my terminal reserve for verifying that. So from my another terminal I am going to apply the restore session. So if we talk about a restore session a little, then definitely there is nothing, that only we are targeting our sample restore stateful set, and as a data source we are using S3 demo that we created, that we mentioned inside our backup configuration, and nothing else. There is some add-on stuff. So our restore session phase is also succeeded. So now let's verify that our restore session is successfully completed. So so here you see that our restore session exists inside that directory. So now if you want to verify that how actually the restore session was, so I want to talk about a little more about the OIDC. Uh, IRSA of the KubeStash. So if I get let's get the YAML of any sample pod which was responsible for taking backup. So this is the sample pod YAML which was responsible for taking backup into actual S3. So if you see that inside the pod there is a mount path of the service account directory, this one, and there is some AWS component value like this one. These all of this stuff KubeStash not inside of this pod. So who was responsible for inserting those value environment, those env values to the pod? So basically those the AWS pod identity warhook who established connect who actually sent a request to the OIDC provider of the cluster, and those a webhook was responsible for generating those value and insert there. So this was the actual behind the scene actually how IRSA work inside in any EKS cluster. So for not only that, KubeStash also work apps code UI. So by using apps code UI, there is no headache. Just for yeah, for example, if I go back to the slide, then for creating role, assigning role, or managing the OIDC, creating the OIDC, all of these stuffs we need are done automatically. So in future we will also look up those features also by through the apps code UI. So if you are interested on UI, just let us know. We'll also give you a demo for the for you also. So that's the end of live demo session, and here is the question and answering session. If you guys have any question, just let me know.
So the guys who are joining, if you have any questions, you can ask them in the Zoom chat, or feel free to raise your voice and ask them in the meeting. We're happy to answer that. Okay, so there is no question at this point, and that's why this concludes today's webinar. Thank you all for your participation. Hope to see you again next time. Our webinars are actively scheduled on our website. Visit appscode.com/webinar to register. Have a good day and bye bye. Thank you.